Hey guys, welcome back to the channel. This video is going to be a update for the car, the motor, and we're actually kicking this off with kind of redoing a project we talked about earlier. And what that's going to be is, I don't know if you guys can see, I'll be pointing to the Evap Purge solenoid line. And I learned that there is a tool that we can use instead of using the two Oerlikon clamps down here. They actually sell a tool out there that can take that line and basically compress it into a quick fitting. And what we're going to do is replace that broken line that was coming up, by the supercharger. What we're going to do is we're going to take that, form it using the tool that we picked up and bought, and we're going to use that tool on that existing line in the car. And what that's going to allow us to do is put a quick connect fitting on that line, instead of depending on basically two fancy hose clamps on that Evap Purge solenoid line, and just use a quick connect fitting. And if we ever have to pull the motor back out or anything like that, we can go ahead, hit that quick connect fitting, remove it, and remove that whole line from the car. And it's one less thing in the way from us trying to put the motor in. So we picked this tool up from Amazon. It is from Orion Motor Tech. Let's go ahead and get this open up. And the other thing I was going to say is this is not just good for quick connect fuel fittings. It's good for transmission fittings. There's also another thing, brake lines. I think there's a third line in there. It's like brake line fittings, fuel fittings, and it's also good for transmission cooler fittings. I think that's the top three. And shout out to LT from Tolman Performance. He's got a YouTube channel. I found out about this tool from him, and because he was working on either his drag truck or his daily driver. I think he's got like a 2019 or 2020 Sierra 1500. And what he did was he added a E85 sensor using the factory line. He put in basically the quick connect fittings on that line. Have some screenshots of that here, and that's how we found out about this. So shout out to LT, and we'll go from there. So, all right guys, I'll be honest, this tool was fairly expensive on Amazon. It was just about $200, and when I saw LT, use a tool similar to this on his car, I was like, yeah, that's definitely something that I want. So, well, that's a little weird. Came with a pair of gloves, so that's interesting. That's about it in there. Then in here is the hydraulic flaring toolkit from Orion, like we said. And let's go ahead and get this open. And here is the toolkit. All right, so you've got your user manual, you've got your plastic foam stuff, and then everything in here is basically just going to be your flare fittings. Now, I'll be honest, guys, there are cheaper versions of this toolkit, and they only come with like one set of flares. This comes with all of them. So like I said, it has the transmission, the fuel, the brake line. Yeah, so that's what the tool looks like. It's basically just a hydraulic tool. You put your flare adapter in here that you want to put in. You put feed the hose in from the front. Squeeze it down, you lock it down, squeeze it down, start applying hydraulic pressure using the handle over here, the lever, and that's pretty much going to be about it. All right, here's the list of flares. There's 45-degree inverted dies. That's basically going to be your brake lines. ISO dies, I don't know what that is. GMTC, so that's GM transmission cooler, ISO adapter, push connect dies, GM fuel line dies. You can buy cheaper versions of this, I think for like 120 bucks, 150 bucks, or spend a little bit more money and get everything. So that's what we end up doing. So yeah, we basically have everything we will need to go ahead and put this flare connector set together. All right guys, I've been messing around with this tool for a little bit, and basically what I did was I put in the GM transmission controller flare right here. So you swap that in down here at the bottom. Then you've got the die itself. Now this is only half of the die, the other half is over here on the floor. So you'll put the other half of the flaring tool inside the tool. You'll stick the pipe down in there. You'll bottom out, kind of like we were talking about. Bottom out in there. You'll tighten everything down, and then you will start to grab the hydraulic handle down here, and you'll start squeezing, and that should pull the tube and the flare, everything down into one, and that will basically crush the pipe that you're running. And what that will do is that will put the flare down bottom here So yeah, I'm pretty sure that's how that's going to work out. I just wanted to kind of mock it up to see how all this stuff is going to work. Alright guys, well, we just tried 4 different times on trying to get this stupid line to crimp, and yeah, it's not working. So, you guys can see we have our line right in the middle there. You guys, it's pointing up right there. Yeah, there's no crimp in it. And I can't get this tool to work. I just measured the thickness of the line. It is 1.35 millimeter, approximately thick. Just one side, one of the walls. And I just reread the tool. It says not good for pipe thicker than 1 millimeter. So we're over the capacity on the thickness of the pipe that this tool can bend. And I literally used all of my strength to try to squeeze that thing, and it didn't do anything. I think what the case is, basically this tool doesn't have the power to go ahead and try to crimp, you know, to flare a line that's thicker than 1 millimeter. And you guys can see that here. Usually you can kind of exceed a tool and it'll work, but this thing, not having it. Now I will say this, the fuel lines in the Corvette are dipped in some kind of coating, and you guys can see it does have a black finish on the outside of it. So there's something on the end there, and I just don't know what it is. So that might be contributing to that thickness. So unfortunately, this tool that was $200 some, yeah, ain't gonna work. So I really wanted a nice quick connect fitting on there. I could pop the line off, pop the line on, and yeah, this isn't gonna work. So yeah, I'm gonna see what the Amazon return policy on this thing is, and go from there, because if I can't use it for this, I don't see me using it anytime in the future, and I'd rather get my 200 bucks back. If it was like a $100 tool, I'd probably eat it and keep it, but this thing being 200 plus tax and shipping, I think it was like 205. That's not super expensive, but also I wouldn't mind having that money back. So I'll get this thing boxed up and see what Amazon will have to say about that. So yeah, learn a lesson from me. If you're trying to do this on the Corvette, this isn't going to work, but if you have a 2019 truck, yeah, I think that should work. I don't know. I'm shocked that he was able to do that on a much newer truck, and I have a Corvette that's almost 20 years older, yet I couldn't use the same tool that he had, and yeah, so this is a big fail. For this next part, we'll be talking over some electronics. What we'll be going over today is actually sensor specific, and yeah, there's a lot of stuff between the LS2 and LS3 that are not the same, so we're going to jump into that right away. Basically, the knock sensors on the LS2, so 2005 to 2013, are the same. So I just took the knock sensors off the old motor, never had a problem with them, and those are right there. The next sensor, this is going to be the cam position sensor. Now, this one honestly was kind of a weird, hard one to find, and what I mean by that is GM part number for this is 12591720. And what I'm talking about there is I saw a lot of conflicting information of the LS2 sensor, the LS3 sensor are the same. You go to Dorman, it's like the same part number for all your C6 Corvette. And I ordered this, I'll be honest, not knowing if it's all exactly the same. So I just went ahead and ordered it. I think it was like 20 or 30 bucks, something like that. And the reason we're going to be replacing it, even if it is the same as an LS2, the cam position sensor, especially on an LS9, is kind of a pain in the butt to get to, because with the old wet sump, you know, you had the big harmonic balancer crank pulleys from ATI. You have that there, and that's kind of blocking the way. And then put the water pump on there, and if you get the fully assembled engine, like I said, it was kind of a pain in the butt to get to. So I already went ahead and replaced it, and I bought the best part number I could find from Chevrolet. So we bought this one ending in 1720, and I can't confirm it's the same between an LS2 or an LS3. I think it is, but you know, I went ahead and bought the one that would fit a 2011 Corvette because that's what the engine harness is out of. So that's the one I bought. Double check your part numbers if you have an LS2, so it's like 2005, 2006, or 2007. Just double check that because you need to make sure you have the right sensor. This is going to be the crank position sensor, and I can tell you this is specific to the LS3. The LS2 is different. The LS3 uses a different crank position sensor. And you know what, guys, now that I'm thinking out loud about this does make sense that they would change the crank position sensor, because the other sensor is looking for, I think it's a 24 or 36 tooth, something like that. And the LS3, LS7, LS9 all use a 58X reluctor wheel. And so the 2011 specific part number is going to be 12703627. So this should fit LS3, LS7. Actually, guys, I know for a fact the LS9 uses a different crank position sensor, but since we're having a 5.3 and basically a 427, I went with the LS3, LS7 style because I'm pretty sure this will fit. And yeah, again, this was like 30-40 bucks, something like that. And then the last sensor, which again I know they have changed, this is the oil pressure switch, and that part number is 12673-134. And I know they changed this because I've seen previously where the early cars and the later cars have a different oil pressure switch, and like I said, so, and also the plug harness is different. So just an FYI, if you guys are doing kind of a weird combo like we are, make sure you have the right sensors. And so that's pretty much going to be it. Everything from the cylinder heads up is all pretty much going to be the same. I've basically been running LS3 sensors on the car for like the last 10 years. I converted them a long time ago, but everything on the bottom end I had not. That was still the LS2 specific stuff. So the MAF, the map sensor, the IAT sensor, that's all basically going to be the same with the LS3 stuff. It's already what we have, and we should be good to go there. So yeah, that's going to be all of the sensor updates. And thought we were going to spend a lot more money than we did. I think we spent roughly, I'm just kind of ballparking this, about 150 bucks for the 3 sensors. You can go cheaper, but honestly, guys, every time I cheap out on a sensor, you end up buying it twice. So just spend a little bit extra money, buy the Chevrolet parts. Honestly, in a post-COVID world, that doesn't really mean much anymore, but I still have faith that the stock sensor is better than a cheap aftermarket one from Dorman or stuff like that. So as for the last part of this video, let's go ahead and just jump into it. So this is going to be the latest and greatest on the engine, the 427. If you guys had watched the live stream, I'd mentioned Ken had run into a problem with the 5.3 block. And basically the problem that Ken ran into was when he put the engine into the machine to hone the cylinders out, you know, those new sleeves that he'd put in the previous video. I think we're trying to get it to a 4.125 as a final finish, but it might be a little undersized, and then he's going to do something else. Yeah, anyway, when he went to put the torque plate on, the same thing that we did here on the 6-liter block happened to him. I think the studs that we're using call for 100 foot-pounds. He put it in at 60, and as soon as the first bolt he put in the block, he torqued it to 60. It spun the threads right out of the block. So the very same issue that we had with this 6-liter, Ken has run into with the 5.3. Now, to resolve this issue, Ken gave me 2 options, basically. One was to go ahead, buy a 1/2-inch head stud kit, get the torque plate, get the bolts, basically the whole kit that we had from Tick Performance. I have since sold that, by the way, so I actually don't have it anymore. Buy that kit, it's like 600 bucks. Have to start over with head studs because we already had custom head studs made, and then also we'd have to start over with head gaskets because we also had custom Cometic head gaskets made. So option 1 is throwing away a lot of money that we've already spent. Option 2 is basically drill out all of the stock size stud locations and put in a time cert. I don't remember the name of the brand. It was either Keen Cert, King Cert, something like that. I'll update that down below. But yeah, so option 2 is what we went with. I think the kit was 100 bucks. It wasn't that expensive. And Ken called the manufacturer and he said, yeah, people are pushing 1,500, 2,000 horsepower on these things, and they should hold up without any issue. So that's the decision that we made. We haven't ruined the block. At least I haven't done it. As soon as Ken called me and left me a voicemail, I could tell he was in a foul mood, maybe a depressed mood. You can just tell something's up. So yeah, when I called Ken back, I was like, all right, man, what's going on? And that's when he told me he put that torque plate on. First bolt he was trying to tighten down, and it stripped right out. I was like, oh my God. Then I told him, like, I honestly didn't know the history of the block, so I don't know how many times the block had been gone through, how many times the head studs have been removed, or the stock bolts and whatnot. So I authorized Ken to go ahead and pick up the kit, start machining the block. It's gonna be a little bit more expensive, but we would have lost a lot of money on the Cometic head gaskets and those custom head studs that we already had made. So I was like, all right, let's just stick with that. Ken has actually already finished this, and the block is just about done. We'll have some pictures here of the time certs or king certs, whatever we're calling them, that he put in. And then here's a little video of the crank that he's working on. So he's working on the Molnar crank, balancing that. And then he also TIG welded on the reluctor wheel. So I believe that's gonna be about it for the machining on the block. I did ask him to put a plug on the dipstick, because obviously with a dry sump car, you don't need a dipstick sitting between the headers. So we're gonna lose a little bit of weight there because we don't have that extra dipstick that we gotta, you know, basically finagle between the starter, the block, and the oil pan, and also the headers. So I'd asked him to put a plug in that. And so yeah, that's pretty much gonna be it for today's video. We went over the electronics for the sensors on the bottom end of the engine, and we also gave you some updates on the 427 block and the crank. So yeah, that is gonna be it for today's video. If you liked it, hit that like button. If you wanna follow along for more 427 updates, we're getting there. Hit that subscribe button, turn on your bell notifications. And if you guys wanna help support the channel, check out all the links down below. I should be able to get you some links for the sensors as well as the tool. That tool specifically came from Amazon. Give you a link to that. Also, make sure you check out our website, BonecrrusherSS.com. Any support you can give there goes right back into the channel. We got t-shirts, hats, sweatshirts, stickers, car parts, used parts, new parts. We got all kinds of stuff on there. Check that out, and that's gonna be it. Thanks, guys. Have a great one.